In this video, we're going to talk about limit. So in this example, we have limit of sine of x over x as x approaches 0. So whenever you think about limit, I want you to, when you see the word limit, I want you to think about the word approach. So as x gets closer to 0, what is the value of y that sine of x over x is approaching? So let's take a look at graph of sine x over x. So I'm going to use a graphing calculator, TI-84, to graph sine x over x, and make sure in calculus your mode is always in radian. You guys remember that in calculus, always in radian, not in degree. So when you graph this, also you want to have a go to zoom and press number 7 for zoom trig, because we're graphing trig functions. So choose 7, you'll get a graph like that. This is a graph of sine x over x. Now notice, as x gets closer to 0, as x gets closer to 0, either from left or from the right, look at the y value. What is the y value that this graph or this function is approaching? As x gets closer to 0, the y value is approaching 1. So therefore, you could say that limit of sine x over x as x approaches 0 is 1. Now we are going to also use table to find the limit. So in order to use a table, let's first press second and window for table setup. And you want your independent to be ask, highlighted in ask, not auto. And press second, table. Now we're going to find out what happens as we put x values that are getting closer to 0, and then find what happens to y values. So let's start from like -3. You press enter. When x equals -3, y value is 0.047. You could also use the arrow to find a more accurate answer. What about when x equals -2? It's 0.4546. What about -1? It's 0.8415. Now, remember, we want to get closer to 0. So what is a closer number to 0 than -1? Well, let's try -0.5. Now you're approaching 0.9589. What about -0.1? 0.9983. Okay, what about something closer to 0 than that? -0.01. Okay, as you can see, you're approaching 1. Actually, it's not exactly 1. It's so close to 1 that it's saying that it is 1. Now, what happens when you put 0? It's error, because sine of x over x, when you plug in 0, is undefined. Remember, limit, the key word is approach. What happens as x approach 0? You don't have to get there, but what happens as x approaches 0? Now this was from the left side. What happens when you approach 0 from the right side? So let's try +3. 2, 1, 0.5, about 0.1, 0.01. You get the idea? I'm getting close to 0 0.001. As you can see, they're saying that it's getting closer to, as we approach 0, either from left or right, we're approaching 1. So as you can see, when you evaluate limit of sine x over x as x approaches 0, the answer is 1. And this comes very handy, so you need to memorize this. So what is the limit of x squared quantity 2 minus x as x approaches 3? The easiest way of finding this limit is use substitution. So instead of x, just plug in 3 and see what happens. So you get 3 squared, which is 9. 2 minus 3 is negative 1. So 9 times negative 1 is negative 9. Now if you graph this and find the y value as x goes to 3, as x approaches 3, you'll notice that the y value of this function will approach negative 9. But the easiest way of doing the limit, just substitute the value and see what you get. That will be the answer. Yeah, let's take a look at this example. So again, let's try substitution and see what we get. You get 4 plus 4 plus 4 all over 4, and you get 12 over 4, which is 3. Oh, by the way, the common mistake is they cancel out the 4 and 4 here and get 8. You cannot do that, so be careful with that. So the answer is 3. Okay, what about limit of tangent x over x as x approaches 0? Well, let's see what happens when we plug in 0. What's tangent of 0? Is 0. Tangent of 0, remember from pre-calculus? Tangent of 0 is 0. And it's 0, so 0 over 0 is undefined. So what you need to do is we need to kind of use manipulation. Remember earlier we talked about limit as x approaches 0 of sine x over x is 1. Well, we're going to use this. So we're going to rewrite this as limit as x approaches 0. Remember, tangent x is sine x over cosine x. And you got all over x. So if you rewrite this, it's going to be limit as x approaches 0 is going to be sine x over cosine x times 1 over x. And you can rewrite this as limit as x approaches 0 of sine x over x times 1 over cosine x. Now remember, as sine x over x, as x approaches 0, that will go to 1. Okay, this will go to 1. What about when you plug in 0? What's cosine of 0? Cosine of 0 is 1. So it'll be 1 times 1 over 1, which is going to be what? It's going to be 1. What about this one? When you plug in negative 2, you're going to get 4 minus 10 plus 6 all over 0. So this is undefined, but if you use manipulation, so we're going to factor this out. So you get x plus 2, x plus 3 on top, and you get x minus 2, x plus 2 on the bottom. So x plus 2 cancels out. Now what happens when you plug in negative 2? You get 1 over negative 4. So this means as x approaches negative 2, that means the y value of this will approach negative 1 over 4. Before I explain next example, let's review. You know that when you have x squared minus 16, the factor of that is x plus 4 and x minus 4, difference of squares. Now, what if you have x minus 16? What would be the factors of that? Well, you could say, what's the square root of x? It's radical x. And the square root of 16 is 4, so radical x plus 4 and radical x minus 4. What if it was x minus 9? Then it would be what? Radical x plus 3, radical x minus 3. So now if you want to find the limit of this, notice when you plug in 5, the denominator goes to 0. It's going to be 0 over 0, so it's going to be undefined. It looks like it's undefined, but if you factor out the bottom, it's going to be radical x minus radical 5, radical x plus radical 5. So what's going to happen is this 2 will cancel out, and you have the invisible 1 on top. So when you plug in 5, you're going to get 1 over radical 5 plus radical 5, which is going to be 2 radical 5. Now in calculus, you could have radical on the bottom, so this is fine, but you should also notice that this is the same thing as radical 5 over 10. So one or the other is fine. Now let's take a look at this example. You got x cubed minus 1 over x minus 2. When you plug in 2, what happens is that you get 0 on the bottom. So it looks like it's undefined. Let's check it out. Do you remember how to factor a cubed minus b cubed? It's going to be a minus b, quantity a squared plus ab plus b squared. What about a cubed plus b cubed? That's the sum of cubes. It's going to be a plus b, a squared minus ab plus b squared. So when you factor that out, you're going to get x minus 1, quantity, x squared plus x plus 1. And you could double check it by multiplying this out, see if you get x cubed minus 1. All over x minus 2. Unfortunately, we cannot cancel out anything. So our technique or manipulation did not work here. So it looks like we might have to graph this and see what happens. We might have to graph x cubed minus 1 over x minus 2. So again, I'm going to use my TI-84 to graph the function. In order to graph that, let's put that in and go to zoom. Actually go to window. I'm going to set it x min to negative 10, x max to 10, and then y min to negative 100 to 100. And the y scale, let me just change it to 10. Okay, and then I'm going to graph it. So notice what happens as we approach 2. As we approach 2 from the left, you notice that y is going to negative infinity. Okay? What happens when you approach 2 from the right? As you approach 2 from the right, the y value is going to infinity. So as you approach 2 from the left, y is going to negative infinity. As you approach from the right, y is going to positive infinity. So therefore, the limit doesn't exist. Limit does not exist.